So moonstones are orthoclases with potassium and sodium, but not labradorite, which is sodium and calcium plagioclase. So one of them is in here, labradorite, which is many colors, sodium and calcium feldspar, and then the potassium and sodium feldspar is this moonstone here, and it's not, it's just white. And why is that? So I was just trying to work that one out. And so the structural color rules that I sort of made up. So sorry, I'm just trying to get my head around things. It's got to be like structures that are kind of small enough to interact with light, and they have to be repeating and consistent. So what I found was, with a bit of searching, because all the sites don't really seem to want to get into the physics and chemistry of it, is they're irregular and they're fairly thick. And this picture here, this one doesn't make sense because it's calcium. It should only be sodium and potassium layers. And they're huge, they're different thicknesses. So that's really thin, and that's really thick, and then that's really thin, and that's really thick, and they're all inconsistent, although they are the right size. So that's the answer. Okay, so they are the right size. They're just inconsistent. So we don't get the colors. We don't get the constructive and destructive interference, and you just get a white reflection. And that's what the moonstones do. Okay.